So, good morning. This session is going to be about large-scale IT forensics data distribution with PowerShell. I'll get back to you shortly what exactly I mean with that. As usual, we'll first spend a minute with our sponsors, without whom we wouldn't be here. Very grateful. I don't want to diminish the others, but I will get back to Iron Man a little bit further, in particular. So, what am I talking about more specifically? We do apprehend a lot of suspects in investigations, or you do searches and find devices in different kinds of crimes. These devices are then extracted and put up onto some sort of storage. And today, one of these devices could be like half a terabyte, readily available. They're usually somewhere around 50 gigabytes when you do extract them. And while we used to have people in like lab coats at a workstation analyzing these, providing reports to investigators, this data is more and more moved into centralized server-based systems where you collaboratively work with the data and correlate it to other devices. And we are talking about target numbers for our purposes of about 50,000 phones on a year-to-year basis. 50 gigabytes, you do the math. On top of that, we have thousands of computer extractions. They're not quite as common today because, like you, all the criminals are using these ones, not their laptops that much. But we do get them quite a lot, especially in child abuse, child pornography, that kind of stuff. And in addition to that, you have all sorts of other kinds of devices, your car, your home entertainment system, whatever. So, about me, the picture looked slightly less of a mugshot before they cut away the bookshelf in the background. But I was going to be a high school teacher, somewhat overly educated high school teacher, but like 94, I hit some bumps. I needed money to pay the bills, and here we are. I'm an infrastructure architect with the police since 2018. The title is slightly misleading because we tend to be all over the place. And I'm a Unix guy, if you ask me. That's where most of my profession's been at. I've been doing a lot of development for and on Linux. I'm also rather proficient in Windows and Mac and whatever, but usually the target environment for the development I've been doing has been Linux. But no one really asked me anyway, so I get to be the Windows guy mostly anyway. The lowercase p police. I was thinking quite a lot about whether this is a Swedish police authority or police agency or force even. I don't really know. You see different in different publications. But the thing is that in Swedish, it's just the police. And in the body of text, it's not even capital P. It's just like water or grass. We're it. We're the one. There's nothing to distinguish ourselves from. And the only difference to this is the security police we have in Sweden. They're like into counter-espionage, terrorism, that kind of thing. They're also our supervising agency, which in terms of IT sometimes gets a bit funny because they're like wee big, and we are not. The agency is roughly 40,000 people. We do IT at roughly 400 addresses around Sweden, from the very north to the very south. And in addition to that, we run IT in all kinds of devices. I mean, a a police officer today do a lot of his work on one of these. He has his radio, he has his body cam. We have thousands of patrol cars with IT systems in them. You know, the bay in the trunk where you keep your spare wheel, or used to when you had one. That's today turning into a small data center of its own with firewall, storage, a GPU-enabled server. And this is weird to us because this is one of the largest police organizations in the world. Which, I mean, Sweden, funny. But the thing is, policing is local. You know the story. You have some community, you get some problems. The lonesome cowboy gets to be the sheriff, and you start developing a police agency. So they tend to be very small. 10 years ago, the Swedish government decided that we're not going to do this anymore. We're going to reorganize the police into one in order to tear down organizational barriers and increase efficiency, but especially turn down even legal barriers for information flow between agencies in Sweden. So a new centralized IT environment for the Swedish police was built. All the fancy stuff, all the border security you can think about, antivirus, intrusion detection, layers of firewalls, you name it, we've probably got it. And which is kind of, we do the same physically. I mean, we have bulletproof doors, but we still need to go outside in order to meet the public. And we do that on the internet as well. But generally, we have all this security. And forensics get to be a little bit of a problem in this, because we apprehend this obvious criminal. We grab his phone, and they're going to walk straight past these security layers and just dump whatever he's found on Darknet or Telegram or whatever onto our storage. Unsurprisingly, security had some thoughts. So we had to figure out how to deal with this. And the thing about being such a large organization, or police organization, there are companies that are targeting police with software suited for our purposes, which are kind of weird sometimes, but they tend to work with small business size organizations, and we need a lot more. So the forensic software didn't really work in this context. We spent a lot of time investigating this, working with organizations, or working with vendors and stuff, eventually gave up and gave them their own network environment. Security is happy. If they blow themselves up, the 24/7 life or death operating system in general is not affected. Fine. The problem is the collaborative systems I was talking about are going to be over there. And we have a wee bit of an issue because the data is in one segment and it's got to be used in the other. And we're working on this. It's a lot of infrastructure. These storage systems across the nation, they're like several petabytes in size. But we are professional architects. We know what to do. We draw a box, right? Arrows and everything. Done and done. The work continues. And I start to think about this old classic for more and more. I think we have to be a little bit more explicit in the middle here. So, but surely someone's done this. We can just go out, buy something, find out what someone else done, and I'll just leave it at that. The short answer is perhaps not. So we started thinking about what does it have to look like really? And this is a wide area network. What really kills performance dealing with these very large file system structures is latency. And Sweden's pretty long. It stretches most of the US, for example, and from north to the south. So we do really have some issues with that. So we figured out that we're going to have some kind of edge computing. These look large, they're not. They're like 1 unit, regular rack servers, and they're still overpowered. What you need is a network interface and the closeness to the storage. With this in place, we kind of figure that we're going to have some kind of general process. It's simplified here, but we have to do some sort of pre-processing before we do the actual transfer. At least probably package it in some way, ship it, and then at least probably unpack it, and possibly do something else. I mean, like inject it into a system or something. And we need something to control all this. To start the processes and to allow an end user, because it's mostly the same end users at both sides here. They're going to start some work and then want to know when they can continue it at the other end. So with this in place, I felt rather confident. Things could go along because I knew that if nothing else showed up or came up as a solution, I could always throw in a couple of Unix hosts or Linux hosts and just bash it away to sort of save the day and buy time to find out what to do next. I also knew that if I did that, I would be stuck with it forever. Because in this area of the police or our work, it's a Windows shop. So I only had Windows resources around. So I had to figure out how to do this the Windows way. And I have an old friend of mine who's been nagging me about PowerShell for years, literally. It's you get these objects, not only text streams in the standard output, and you get to manipulate them, and you know all that, the tab completion. Like, oh boy. And I was like, sure, but I don't have a problem for that. But now I actually got to literally call him up and say, you know what, I found the problem. Can we talk about it? And his name is Staffan Gustafsson. He's a brilliant software engineer. He's been here a few times and is involved with PowerShell maintenance. So you may know him. So how do we move files fast? That was another question I wasn't quite used to deal with on Windows. Well, it turns out it's robocopy, right? You all know this. Nothing new to you. And this is sort of fine. The interface is weird, but okay. Well, when I want to traverse a structure to find out what's there, it's still robocopy. So, okay. And if I want to delete stuff fast, it's still robocopy. All right. Fair enough, you have to have some kind of wrapper around this. I started writing a few lines of code myself, but surely someone must have done this before. And in this case, many have. The one I went to was Robocopy PS by Simon Bergwall. That sounds suspiciously Swedish. And that is because it turned out that it's actually Swedish. It's been very helpful in doing some amendments in order to support our use case. We use it a lot. And we do one other thing that I'm not going to talk about much today, but we do virtual hard drives for wrapping this data up. Just take my word for it for now. The last thing was when I discovered PowerShell Universal. And that was really a kind of eureka moment for this, because it solved that part. I immediately understood that I could use this to provide do both a command, schedule tasks, and also provide users with some kind of user interface and feedback. So this was really, I'm a huge fan of PowerShell Universal. I think it's great. It's a long time since I was so excited about a piece of software, and I'm kind of stumped and a bit starstruck by having met Adam here. But I knew that with these pieces, I could build a solution. So let's leave it at that and go to the real stuff, hopefully. Now, we do development anything but locally. This is a development environment. It's rather far from this poor thing. So if you have any special chance to the demo gods, this is your chance to shine. This is the major interface. It's in Swedish. I'm sorry, I apologize, but we're a Swedish shop. We don't do any other languages at all, apart from when interacting with people, obviously. But we expect people who use our stuff to actually understand this. But you get the gist. We have this notion of a starting point, an end point, and some kind of flow in between. So what you see is data that were picked up at the starting points to be ready for transfer. And since these are large folder structures, sometimes it can be like 10 terabytes in size, I cannot really automatically decide when this is ready. There's no way to know that. So I'm sort of dependent on someone else to tell me that, yeah, they're done, start the job. So this is what you can do here. I'm not quite sure if I'm authenticated yourselves. And I also do the very least I can get away with. I could do this in a nice interface and say, but our users are kind of technical, they're in forensics, so I just dump them into the PowerShell Universal interface that already has everything I need. They're not admins, so they see slightly less. And well, you can see the propagation of the job. A really nice integration with PowerShell features such as the progress bar, as much as the progress bar actually works in modules and stuff. We'll go back. We'll see that job is started. You can notice a small thin green light line up there. I'll get back to that. We can start another job. This is a smaller one. And I mean, it's not really extremely exciting. And there's a lot of things going on in the background, but you can't really watch it, can you? Now we should have 2 jobs running. These development servers are really, really, really tiny, so it's not that fast. Now you notice the progress bar over on the top became yellow. The thing about this is, the saying that any better plan never survives the first contact with the enemy. I mean, it was obvious to me that you sort of prepare some work, you go to the interface, launch it, then go on to the next stuff while that runs. That's not how they did it. They prepared all the work, spent all day, and at 4 o'clock in the evening, they went click, 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 shut down the computer and left for the loved ones. Well, I did not. Right? I was in there like chewing my nails and hoping things wouldn't explode until the load came down. So I had to figure out, and I don't really have any way to communicate with end users. I have this small information bar I can use up here, which I also needed to introduce. There's no real information channels to this particular community. So, and I tried to figure out, how do I get through? How do I explain this to them? And how do I, when new people come in, how do they know? So I came up with this idea to sort of show some sort of temperature, to give us a hint that I started to feel uncomfortable about things. And I never explained it to anyone. I've never told anyone, but the behavior just disappeared overnight. Boom, gone. That was kind of funny. Anyway, go on this. You see, we have the list of previous jobs. These tables are searchable to find stuff. I mean, this is pretty much all it does on an interface part of view. You will have some kind of statistics to follow up what's going on. This is also, in the beginning, I did this as small as I could, just asking PowerShell Universal for information. this was in version 2, and it was a limited history at that time. And as this system got used more and more, this history shrunk until it was only a couple of days. So I had to figure out something else, and then I had to start using some kind of database as a background storage for this. What's kind of important is I also have the flows that have not been used. So I can talk about why that is, if it's something we should remove. We also, this is in the forensics network was sort of still evolving, so we didn't have all the kinds of system utilities you normally have in kind of monitoring. So I had to come up with some own solutions. So I have some, I can see a bit what happens on the different nodes with regards to processing and networking. I could also follow up on the patch status, which is to make sure that antivirus is updating all these nodes and that kind of thing. And I guess that's mostly it. There is, after a while, we started to also add a concept of automation, because we have, on the forensic side, we have additional sort of pipelines. They're actually based on that kind of software for doing the actual extraction. We try to automate that process as well. I mean, 50,000 phones, they're like 300 people. That's a lot of work. You need to start automating that kind of way. And that was also one of the reasons I did this in PowerShell, because I had some opinions about them having to start to automate their processes, use scripting languages in order to improve their own workflows. So I had like a hidden agenda sort of. So a system can drop off a JSON file, which sort of corresponds to the click I did in the first interface to start the job. And we're, in addition now, this copying of data to this export folder to get it shipped is starting to get cumbersome. So we're improving this now to add a command line interface where they can start this kind of automated jobs with just a simple command line, and we can pull the data from where it's at without this additional copy to save them some work. I can show you that later. So that's kind of it. We'll just take a brief look at what things look like. Let's get rid of that. This is sort of the structure you have in your PowerShell Universal project. It's all GitOps based. As a sort of, with a development background, PowerShell Universal is really, really developer friendly. It's sort of built in GitOps from the beginning. So I do this kind of work. These are scripts typically registered as jobs in the interface, or they're registered as scripts, but they're used to execute jobs. I mean, this task scheduler part of PowerShell Universal. So there is configuration. We'll look at that one. Here you have this kind of concept of a route with the starting point, the end point. You have the nodes that you saw in the overview that are to be involved in the different steps. And you have the concept of a flow, which is sort of the process, what's going to happen on the road here. And it's mainly done in this, when you press this button, what happens is this script, the transfer file inbound, it was called that because I, at that point, expected there to be another one that was outbound with some other logic. It's not, it's the same now. But due to how PowerShell Universal is constructed, I, at that point, needed a name to remain, so it's not refactored. I could do that now, actually. So there's a lot of boilerplating going on, setting up sessions to all this computer. I mean, I have all these issues with remote PowerShelling into another domain without trust. Also, the double hop to a file server across domains without trust. So that took some figuring out, but we got it done. But when all this is set up, I do an import module of that flow that I got from the configuration. And in that module, I expect there to be a certain method with a certain signature. This would have been a nice use case for like classes, but this using import thing got kind of in the way, and I didn't know any way around it. I'm not sure if it's really that helpful anyway. So we can look at one of these, and let's look at something a wee bit different. We're going with this one. So this is NECMEC flow, which is a little bit different from the normal ones. It has this function. Well, NECMEC, I don't know if you're aware, it's not so National Center of Missing and Exploited Children. It's a national non-government organization in the States dealing with lots of things, but among other things, abuse material reported from like Facebook, Instagram, whatever. They take that, analyze it, and if they think it somehow involves Sweden, they sort of provide us with this information to deal with it. And these are like tens of thousands of issues every year. They may or may not be really interesting. I mean, it is what it is, but we have to go through it somehow. So we have a flow that helps with this. We've been doing several different attempts. They're generally zip files with some, with the media itself. Could be something that's uploaded before or after as well. There's a metadata file that sort of explains. It could be a profile image, that kind of thing. There's some metadata that describes what they know, IP addresses, accounts. It comes in a zip file, and we get these from sort of a number of different ways, so they can look a bit different. So there's some kind of fuzzy logic, but essentially we expand this, and we convert this structure to VIX, which is open format for cases of this kind of media-rich stuff. And then after that, we upload it to a system called Griffy, which is kind of the one analyzer system we have that I can actually talk about, because it's an open procurement, and it's sort of the de facto standard in this business for child pornography and child abuse images. And these, I wanted to highlight these because these are the parts of this that were sort of actually unofficially kind of made public. They're in my GitHub repo though, but we do have a few models to interact with Griffy for those who are interested. Most of the other stuff is rather internal, apart from the concepts, but these parts are kind of neat, and we did publish them in the first case to the vendor, which is today Magnet Forensics. They bought Griffy for a couple of years ago to show them how we use their interfaces and to provide them with possibilities to repeat issues we had. We ran into some concurrency issues within Griffy and things like that. So that's actually, it's not really in the gallery yet. I'm sort of looking into doing that, but I haven't really got time. We're not really an open source shop in general though, apart from that. Me and a colleague of mine is working on that. It's been fun. It's sort of very, very slow progress. And it's not the security people, it's more management. And we talked to human resources, employer branding is a thing. I mean, we're recruiting people, and we thought, yeah, we can show ourselves on GitHub. That would be great, wouldn't it? And they were just like staring blankly at us. And what do you mean GitHub is a social media? And we kind of gave up for a while, but we'll be at it again. The important part here is a Griffon JSON parser, because these JSON metadata data structures, they can be like 1 million files. The JSON files get to be several gigabytes large. And if you naively try to parse that into an object structure, will like convert to JSON or convert from JSON, or regular .NET high abstraction interfaces, you get to watch your computer slowly burn up. Yeah. So this is an stream-based, event-oriented parser based on Newtonsoft to get to the interesting bits of this JSON file. Partial metadata, which we then can get in like no time. And we can also get the media objects, which are like millions, or could be millions, in a stream while parsing, that we can then process on the fly in another thread or multiple threads in order to speed up things. So that's that. And I think we officially reached this point. If there are any questions, I'm happy to answer them. Otherwise, I can bore you with the details of this VHDX thing. So let's do that. The thing is, we're moving large file structures across these storage systems, is that the storage systems are clusters. I mean, there are like 30 nodes or something in a cluster. They have like 10 petabytes of storage. And typical file system operations, such as create file, rename file, delete file, are atomic across a cluster. If you and someone else creates the same file at the same time, one of you will get the file handle and the other one will not. And you can imagine what that means when you start to create 1 million files on a file server. It needs to synchronize this for each and every operation, add 10 milliseconds of wide area network latency on top of that, and you have yourself an issue. So what we do is we try to get the forensic people to use VHDX files, virtual drives, to put their case into, or their individual extraction in a way, because they were only individually working with that. And what happens is that you hide the file system operations from the file server. They are local to you. So you take away all that synchronization going on in the file server, which only sees I/O, and it's very good at that and can parallelize that. And you get this container, and it's a lot faster. The only real drawback is that you can only mount a virtual drive on one computer at a time. I mean, it gets locked, so you can't share it. You can't work simultaneously on it. But that may actually also be a feature in this context. And when we talk speed improvements, we're not talking 20%. We're not talking 200. We're talking like 2,000% performance increases. And I can tell you a story I had when we were doing this. We got into these performance issues. It's a wide area network, especially up in the north. Their storage clusters are they're far from most of them. Anyway, I mean, you can't avoid it, long distances. And I had a forensic guy calling me, really frustrated. And I was literally, what the fuck are you doing kind of call. He was really, really, really upset. And we had to dig into this. And I had to, we cooperated around this, and I could show him what the problem really was. It wasn't that the file server was bad. We buy some really expensive stuff. It was just the latency that hit him. And we started working with this, and I showed him this feature, how to work with these virtual drives. I showed him Fislösen and how he could work with that. And I didn't hear from him, and we had to do a report of some kind. I called him back just to hear how things were going. Had he given up? Well, I don't know. And he was a completely different person, really, really happy. And he was talking about how working with his VHDX containers saved him like days of work every day. It was so much faster for him. Even when he worked in his own environment in the local office in Luleå where he sits. So that it's something to consider if you have that kind of problem. Anything else? Boyo? Yeah, go ahead. Yeah, I mean, this is still sort of a one-man shop. I'm gonna have to move this. I'm gonna have to leave this project. We as architects, we're in the operations. We get to have pet projects. This is mine. But I'm gonna have to leave this now over to the forensics and do other stuff. But what it's not really that strange. We can just do well. We can, for example, I mean, this is the development environment. Since I'm only one person, I don't. What you would normally do is that you'd have a PowerShell Universal running on your own development machine, working with that interactively. But since I'm the only one, I don't really care about that. I have my development service. I work with that instead. But currently I don't really work on it as such. You saw this information message at the top. It was created to show people when there was some kind of interruptions going on in the network or whatever. Let's just take that away for now. I'm not quite sure why. Alert. Let's just set that to null. So this is just a regular Git view. So well, whatever. Get rid of message of the day. Oh yes. So we're committing that change, pushing it to well, our own repository. We're not doing the Azure dev thing. Right? we're strictly in house. There's no cloud, and that makes PowerShell development kind of a pain because it's sort of assumes that you're on the network. Okay, so that's pushed. Let's go to our repository. Now, actually, the development server, I'm going to look into that shortly. This is the project. We'll have my commit somewhere. We'll get back to that. If we look at the PowerShell Universal, it will, this development environment, it will continuously pull from the regular master branch. We can see it in here. Here we have the commit I just made. Now, I don't automatically restart the interface. So it's still there. You could have it to automatically restart. Then we have automations or the script user interfaces or what used to be called dashboards. They have, Adam has updated the nomenclature to something more up to date. So it's apps now. This is a dashboard. That was view. That was not my intention. So I can restart it in order to reload it. And the user experience here is that you sort of have to log in again. We are using Windows integrated authentication, Kerberos authentication. So typically it just refreshes. Since I don't have a lot of data input, it's not really an issue for users. And it's still there for some reason. This is a demonstration for you. Funny, should have gone. Yeah, this is what you get. It should be just there essentially, but let's see what I actually did. Well, that's gone. Is this the right one? Yeah, it is. Oh, I can't really tell right now up on stage like this, but it just pulls down the change. You saw that at least. I'm not quite sure why it doesn't. It might be some issue with its actually loading this from another file right now. Typically, it would sort of just get the data, and when you reload, it's gone. And with the other script, it's just there. It's just a dashboard. You really have to restart. And then if we go back to Bitbucket, what I would typically do then to get this into production would be to create a pull request. I'm not going to do that now, obviously. And create a pull request like this. Have the glorious review process thing where I myself look at my own code and think it's great. And push it to the production branch, and that will end up in the production environment. So that's typically the workflow. Hopefully you have some friends who can look at your code and prevent you from doing stupid mistakes, but I don't. So where we are at now at the agency is that we use this. A fun part of this is that the client group, the Windows client group, they're dealing with, I don't know what they have, like 45,000 clients or something like that. They have portals towards end users to get some things, especially in the development environment. We can sort of get virtual machines for development. You can order them in a portal sort of thing. They need to replace that portal they're based on. And they found out about PowerShell Universal a completely different way. And they're sitting in like the next room, but never mind. And it was the licensing people that told them that, hey, we're using this already. Go talk to Fredrik. So I'm thinking about sort of ditching this pet project and perhaps try to work a little bit more with them to help them get started. Because if you're coming from a sysadmin background and not the development background, I cannot have both, then it might be a little bit daunting. It is a framework, it is a platform. You have to learn quite a lot of stuff. But when you do, there's an awful lot you can do with this. There's more than one time when I've been sitting and thinking I'd just throw out some stupid system and replace it with PowerShell Universal and a few scripts and we would be fine. But that's not my day job, so I try to stay away from that. And with that, it's 9:45. I thank you very much for coming here and listening.